Today, I want to talk about something that has genuinely been bothering me. Something I think every developer working with AI is going to face. I call it the supervisor's dilemma. Let me take you back to 2022. GitHub Copilot had just come out, and for me, it changed everything. I still remember debating whether it was worth paying $10 a month. That debate ended the moment the free beta ended, because GitHub Copilot was good. Really good. It saved keystrokes. It handled the boring parts. The boilerplate Java code I'd already written 100 times. But here was the important part. I was still driving. I still designed the system. I still debugged the hard problems. I still held the architecture in my head. Copilot was a tool, and I was still the one doing the work. Now fast forward to 2026. Everything feels different. Vibe coding became normal. You give AI a high-level prompt, and it gives you an entire feature, not just a function, not just a class, a whole feature. And the output, it looks clean. At first, that felt incredible, but after a while, something started to bother me. If the AI is writing the code, what exactly is my job now? And more importantly, if I didn't write it, how do I know it's right? How do I know it's maintainable? How do I know it's secure? That question sent me looking, and eventually it led me to a paper. In January 2026, Anthropic published a study. The title was How AI Impacts Skill Formation. And when I read it, I had that rare feeling of seeing something vague suddenly become clear. Because it put numbers to something I think a lot of us have already started to feel. Here's what they said. They took developers and asked them to learn a new Python library. One group had AI help, plus web search, plus documentation. The other group had just web search and documentation. Then they tested what people had actually learned, not what they completed, what they learned. The result is negative 17%. The group using AI scored 17% lower. 17%. That is not small. Let me put that in plain English. 17% is roughly 2 4-letter grades. If you are getting an A without AI, now you are around a B minus. If you are getting a B, now you are in trouble. And this wasn't random. The result was statistically significant. The p-value was 0.010, so this was very unlikely to be noise. But what really got my attention was where the gap showed up. Number 1, debugging. That was the biggest weakness. Number 2, conceptual understanding. People were using the library without really understanding how it worked. Number 3, code reading. That gap was smaller because both groups still had to read code. But debugging, that matters. Because if AI is generating the code, debugging is exactly the skill we need to in order to supervise it. And that was the first thing to weaken. Now here's the part I found genuinely surprising. You would expect the AI group to finish much faster. They didn't. There was no statistically significant difference in completion time. Why not? Because a lot of their time went into talking to the AI, writing prompts, rewriting prompts, trying again, clarifying what they meant. The time saved writing code was partly spending on managing the tool. So why does this happen? The paper uses a phrase I think is exactly right. The exoskeleton effect. Think about an exoskeleton. When you are wearing it, you feel strong. You can lift more, move faster, do things that would normally be hard. But take it off, and suddenly you realize the strength wasn't really yours, because your muscles never had to develop. That's the risk with AI. It can make us feel more capable than we actually are. And then the moment the moment something breaks, the moment we have to reason, the moment we have to debug, we find out that we never really learned. And underneath all of this is a deeper point. Errors are not just frustrating. Errors are how we learn. The control group, the group without AI, ran into more problems, more mistakes, more dead ends, more confusion. And yes, that felt worse in the moment. But those errors forced them to learn. They had to read the docs, form a hypothesis, test their understanding, adjust their mental model. The AI group had a smoother ride. Few errors, less friction, a cleaner path. But there's a cost to that. No struggle, no skill. So, what do we do with this? Do we stop using AI? No, that is not realistic, and it's not necessary, because the study found something important. Not everyone using AI performed badly. Some participants did just as well as the control group, and when the researchers looked closely, they found patterns. Three ways of using AI that seem to protect learning. I'm going to phrase them as three personas. Persona number one, the conceptual inquirer. This person does not mainly ask the AI to do the work, they ask it to explain the work. So instead of saying, write a function to connect to the database, they ask, what are the trade-offs between using a connection pool and opening a new connection each time? That is a very different move. One treats AI like a junior engineer you delegate to. The other treats AI like a teacher you learn from. Persona number two, the first comprehender. This person accepts a simple reality. Sometimes you do want the code. Sometimes speed matters. But they follow a rule. Generate first, then comprehend. Never skip step two. They let the AI produce the code, but before moving on, they make themselves understand it. They explain it back in their own words. They trace the execution. They annotate the logic. They ask, would I know how to fix this if it broke? They turn code generation from a shortcut into an active learning exercise. Persona number three, the deliberate debugger. When something breaks, they do not immediately dump the error into AI. First, they form a hypothesis. I think this is happening because. Then they use the AI to test that hypothesis, not replace it. And finally, they implement the fix themselves. That changes debugging completely. It stops being a rescue operation and it becomes a thinking process, almost like running an experiment. So let me come back to the original question. If AI writes a code, what is my job? supervision, but not passive supervision, not just skimming the diff, not just clicking approve, not just trust that clean looking code must be good code. Real supervision, the kind that requires understanding, the kind that requires judgment, the kind that requires debugging skill, the kind that requires actual technical depth. So if I had to reduce all of this to one line, it would be never outsource your thinking. That is the whole message. The developers who thrive in 2026 and beyond will not just be the ones who can generate the most code. They will be the ones who can verify it, direct it, challenge it, and supervise it. But that only happens if we are intentional, if we resist the habit of letting the machine do the thinking for us, if we accept productive struggle, if we keep building the muscles that the tool is trying to replace. Because the future does not need more passive users of AI. It needs supervisors. Thank you for watching.